Hello dear students, welcome to ECE Academy Benefactor. The topic of the class is a decoder. The topic is from Combinational Logic Circuit. Subject name is Digital Electronics. In this class we will be seeing the definition of a decoder, applications of decoder and 2:4 decoder logic diagram and its truth table. Let us start with the definition of a decoder. Decoder is a multiple input, multiple output logic circuit which converts coded input into coded outputs, where the input and output codes are different. So, decoder is a combinational logic circuits with multiple inputs and multiple outputs. It is used to convert coded input into coded output. This is the general structure of a decoder. It is having n is to 2 to the power n decoder. This is a way of writing. N is number of data inputs, n data inputs. 2 to the power n is output, possible outputs. N inputs, 2 to the power n possible outputs. To enable the decoder, we must connect enable input. Okay, we can connect enable inputs or one enable input is enough. Applications of decoder. We can find the applications of decoder as it can be used to implement combinational circuit. It can be used to convert BCD to 7 segment code. That means it can be used for code conversion. BCD code to 7 segment code, and this 7 segment code is used in LCD displays. It is used in memories to select particular register. So, these are the few applications of decoder. Coming to 2:4 decoder. 2:4 decoder means 2 inputs and 4 outputs. This is a block diagram of 2:4 decoder with 2 inputs A and B and 4 outputs Y0, Y1, Y2, Y3. These are the outputs. And to enable the decoder, we need to connect an enable input. So, these are 4 outputs and A and B are inputs. Okay. So, let us see the truth table of 2:4 decoder. Inputs, truth table is comprising of inputs and outputs. Inputs are 2 inputs A and B and 4 outputs. 2:4 means 2 inputs A and B, 4 outputs Y0, Y1, Y2, Y3. And to enable this 2:4 decoder, we are having one enable input. In the first condition, when the enable input is 0, A and B they are shown by cross mark. It means it is a do not care. That means A can hold 0 or 1. Similarly, the B can hold the value 0 or 1. So, when the enable input is 0, whatever the values present at A and B, all the outputs will be held at 0. That means the switch is off, the power is off, enable is off, enable is active low or enable is 0. So, whatever the inputs present at A and B, all the outputs will be held to 0. So, now let us see when the enable is made 1. So, for 2 inputs A and B, we can write 4 possible combinations as 0 0, 0 1, 1 0, 1 1. For these 4 possible combinations, we have made enable as 1. So, when the inputs are 0 0, Y0 output will be high. When the input is 0 1, Y1 will be high 1 and all other inputs are 0. When A is 1 and B is 0, the circuit is so designed that Y2 will be high, that is will be set to 1 and all other outputs will be 0. When both the inputs are 1 1, Y3 will be high. So, when enable is high, then only based on the input condition one of the output will be high. Okay, so let us see the logic diagram of a decoder. So what is when will be y0 active? Y0 will be active when A and B are 0 0. So for 0 0 condition, what is 0 0? A bar, B bar. When y1 will be 1? When it will be 0 1. 0 1 means A bar, B, like this. So y0 output is 0 0. So 0 0 means A bar, B bar. Y1 means 0 1, A bar, B. So this is 0 0, 0 1, 1 0, 1 1. Okay. So how they are connected? We have taken two inputs A and B, and another input of A is connected to a NOT gate to get A bar. So A bar, B bar. So these are the input lines, and enable input is given to all the AND gates to make the output to be in the active stage. So for y0 it should be connected to 0 0. 0 0 means A bar, B bar, and enable input. Okay. Now coming to y1, when y1 will be high? When it is connected to 0 1, A bar, B. y2 means 1 0, A and B bar, and enable also connected. Now coming to y3 is 1 1. 1 1 means connected to A and B, and also connected to enable input. So when the input is 1 1 and enable is high, y3 will be 1 and all other outputs will be 0. So what will be the code formed here? 0 0 0 1. So here the input is coming as 1 1, output how it is coming as 0 0 0 1. When the input is 1 1, the output is coming 0 0 0 1, y0, y1, y2, y3. Okay. So this is how the logic diagram of 2:4 decoder is drawn. This is 2:4 decoder logic diagram. So the three important points here you have to take care is, here two inputs are decoded into 4 outputs. Two inputs are decoded into 4 outputs. If enable input is high, equal to 1, then only one of the outputs from y2 to y3 is active. For example, if enable is 1 and inputs are both A and B 0 0, then y0 will be active and all other outputs will be 0. If the enable input is 0, if the enable input is not active, then all the outputs are 0. So this is how the 2:4 decoder works. This is a logic diagram. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.